Hello, everybody. Welcome to IST 140. I'm, of course, Professor S. This is today's lecture. Let's get into it. Let's see if there we go. All right. So today what we're going to do is we're going to be learning about how to get Java to work on your computer. Really, that's what we're going to do. And to test it, we're going to have it print hello world. So in order to kind of understand that, we got to kind of understand, or in order to do that, we have to understand Java a little bit. Because the thing is Java is designed to be easier for developers to learn, but it's not necessarily intuitive for very beginner programmers. So the idea is like there's going to be a little bit of just go with it for the beginning. So like, for example, this is our first program, okay? And this line right here, that's the line that we're going to be doing stuff. Like that's the thing that says print hello world. And again, we'll show this in the IntelliJ, the IDE, and we'll talk about what that is in just a second. But this is the line. But notice that we have two other lines before it and two lines after that, and we need all of these in order for Java to work. And so, like I said, there's like a little bit of like, you kind of just got to go with it, because the idea is like, we'll kind of make sense of these things. So like, for instance, this whole thing right here, this is the main method. Every Java program has a main method. And we'll go into methods later in chapter 5. This is a public class, and we talk about public classes in chapter 8, and it's probably outside of the scope of this class. But you can see it in Zybooks if you want to get to know it better. But the thing is like, if I were to go into these now, it'd be really confusing. It's kind of easier just to say, just know this is the beginning thing. We have to have this thing that's called a main method in the beginning. That's the thing in the green. And in that main method, that's where we're going to start doing stuff. Okay. Now, a little bit more about Java is that Java is what's called a high-level program, which means there is a low-level program language, right? So a low-level programming language, think that's like assembly and machine code. That's where you have the ones and zeros and things that are that are taking those ones and zeros and saying, this is what that means. It's not user-friendly, but it's super computer-friendly. Now, not too many programs not too many people are programming in lower-level languages. It's not that it's not used, it's just, as you'll see with the Java, it's much more, well, I mean, I guess maybe you won't see because we're not going to be working in assembly, but the idea is that it's much more user-friendly, and that's something that people value. One of the reasons why we're able to stray away from that is because space is much cheaper than it was even back when Java came out. As you notice, hard drives get cheaper and cheaper for the same amount of space. Okay, it's one of the nice things about technology. But anyways, other high-level languages include Python, C++, Ruby, SQL. Like there's like tons of them. The idea is like those high-level languages. There's just so many of them. It gets to be more of a spectrum of high-levelness, so the higher. But it doesn't matter. The idea is Java is a high-level language. And high-level languages means that it's more user-friendly, and two, it's a little bit more efficient with your time. So you can do a lot of those higher-level languages. You can do one line of high-level language can translate to multiple lines of assembly or low-level language. So it's one of the other perks. Anyways, as far as Java works, it works very similar to other languages where you have an IDE and the language. And so the idea is like you use the IDE, and we'll go over what that is in just a second, to understand the language. Also, like many languages, Java has a compiler. And now that's about where things end. So Java has a lot of quirks in these regards. So if you notice up at the top, we have the editor, which comes up with the file, the source file. Think about it that as the code that we're going to write. And you put that code into the compiler, and it translate into a class file. That's also known as the bytecode. And it's not quite assembly language, but it's something that the Java virtual machine understands, the JVM. So Normally, languages that have compilers, what they do is they compile it into assembly or something that the computer can understand. But Java compiler converts it into the bytecode, which is something that the JVM understands. So the thing is like Java, anything that has that JVM, that Java virtual machine, can read that bytecode. And that's kind of the whole point of why Java was kind of invented. So in the 90s, people were first starting to put computers like in everything, if you will. There was started to be interesting sensors like in microwaves. That was kind of a new thing. But now we have computers in everything from our watches to our sofas to our light bulbs. Like everything almost has a computer tied to it, right? But in order for us to effectively use some of those things, they need to be programmed, right? Some of it uses Java. And so in order for Java to work, it has to have that JVM. And so it uses that bytecode to read the JVM in that device uses the bytecode to read it to do whatever it's supposed to do. Okay. So maybe you're wondering how, like, does it always require a JVM? Yeah. And in fact, you already probably have a JVM on your computer right now because it's a very typical thing to do little things in online or whatever. Your computer probably has it on it, but it does. But the thing is in order for us to edit the software, we need a JDK or a SDK, a software development kit, a Java development kit. That's what we need to in order to run. So as far as this flowchart is concerned, the JDK and the IDE work hand in hand. So think about the JDK as being the programming language, and the IDE is how you interact with it. Okay, and this is typical of like a lot of languages, except JDK, we're going to call that the Java development kit. And so anyways, we interact with the language with the IDE, and this is not unusual to Java to use an IDE to interact with the language. But we're just going to be using Java. So anyways, IDE stands for Integrated Development Environment, JDK, Java Development Kit. The IDE helps with a bunch of different things, such as helps with debugging, helps with like making sure your syntax is right. It kind of makes it easier to read because it color codes different things like strings and classes and methods and things like that. And so it's great in that regard. But really, you don't really need an IDE. I mean, we're going to lean really hard on it, so you might feel like you need it. But in order to run, you don't really need it. You could just do the JDK. In fact, you can write code in Notepad or in Word or things like that, and that can work. The IDE is great because it kind of fits on top of that language so nicely that there's even a compiler button and all that sort of thing. Like it takes more effort if you're just using Notepad and Word, and we're not even going to go that route because it's a lot of work. But you could do it. It's possible. We're just not. So we commonly have been referring to Java as a language, right? So like a high-level language and that sort of thing. And it works very similar to the English language in the way that errors work, right? I'll make that comparison. So we have compile time errors, which we don't really have a compile time error technically in English language. But if we compare that to speaking in English, there's things that I could say that just don't make sense because that's using the syntax incorrectly. And so we're going to kind of use compile time and syntax errors as kind of a synonymous thing, just like we're going to use logic and runtime synonymously. But the idea is that a syntax error is a mistake in the language rule. So the example that I have up above where it says, I happy Java. Now those are English words, but they don't make any sense, right? Because it's violating how English works. Okay. This is a form of compile error. Now, the runtime error, these are errors that essentially happen after you compile. So the compile time error, these kind of prevent the compiler from compiling. The runtime error, these are things that happen usually after. That's kind of the rule of thumb. But anyways, these are like also often thought of as logic errors. So the syntax is fine, but it's still a mistake. Like for instance, you know how the slide is white? If I were to say that in the sentence, the slide is all blue, right? Now, it's not, it's white. So if you have it as blue, you need to adjust your screen. But the point is, it's like, notice in me saying that it's blue, it's still English that I'm speaking, right? And if you have trouble understanding what I'm saying, it's not because I said English wrong. It's because the screen's not blue, it's white, right? And so that's a logical error. Another example of saying a logical error is if I say 5 plus 3 is 15, right? So syntactically, you could say those things, number plus a number equals a number, but that sequence of numbers is incorrect, right? Logical error. Now, before we start programming our first program, which is the one that I gave you before, the thing that Java does that it requires for a syntax is something on each line. Like for each line, you're either have a semicolon, an open braces, or a closed braces. So the thing is, it's like Java is made up of blocks and lines. Lines are punctuated with semicolons. Blocks have those open braces and then closing braces. So you know, like we had the main method. If you look back to what the main method looked like, notice that on that line, it ended with a braces, and then we had the line that says system.out.println hello world, and then below that was the braces. So it closed that block. So that block was the main method. And then the whole block. So the idea is like there was a block and a block. Okay. We'll get into more blocks later. I just wanted to kind of show like how the punctuation worked. And so hopefully you'll see it as we go along. Anyways, the IDE that we're going to be using is IntelliJ. And in order to make things work, we're going to install the IDE first and then do the JDK. And we'll walk through the different ways to do that, whether you're Mac or a Windows. Okay. Anyways, let's go into Canvas real quick and see this in action. So here I am in Canvas, and what I did was I opened up the page that says installing Java, and that's what we're going to use. You can install IntelliJ locally here, and we'll click on that in just a second, or you can do the VLabs, and I'll do that after I go through the installing process. Okay. So anyways, let's go into here. So when you click this, you go to the IntelliJ or the JetBeans site, and it talks about IntelliJ IDEA Ultimate. We're not using that. We want the community version because it's free. Anyways, make sure you choose the right operating system, and then hit download. Now, if you are a Mac, I had issues with this when I recorded this today. So when you do Mac and you go down here, it might not work. It's dependent upon your chipset. So if you install this and it doesn't work, like it doesn't say that it works with your computer, delete that file. And then when you go in here, instead of this file, click this one. Okay. And it'll start downloading that file. It's not going to work on my computer, so I'm going to cancel it. All right. Anyways, here, we'll go into this. Let me show you what the VLabs looks like. So the idea is that this is the same that you would get if you were at an IST computer lab computer. So you click on it, and it takes you to this. And so then you just log in like you would, so your username and your password. And so then here it's opening it up. Give it a second to figure out what it wants to do. There we go. And so now here is our thing, and you have access to all the, if you're an IST student, you have access to all the things. So if you could start, and it's in here, let's see, JetBrains. There you go, IntelliJ, right there. So open that up, and there it is. Okay. I'm going to get out of here. All right, there we go. Close it out. But then anyways, that's how you could do it on the cloud. Anyways, let's go into IntelliJ right now. So here when you first open it up, you're asked to start a new project. Okay. Opened off screen. Anyways, I'm going to call this, I don't know, first program, or week 1. We'll call this week 1. We want Java and then JDK. You'll probably have nothing there. So when you click on it, you could click download JDK and you get all sorts of options. I like the Oracle Open JDK because Oracle's the current developer of Java when this is recorded. So you download and you're good. I already have it installed, so I don't need to download it again. But anyways, if you are able to select one, then you're good. Then click create. And then you have the JDK or the IntelliJ as a opening thing. Now, when you open it up, you get something that kind of looks like this, right? And so what you want to do is if you right click on SRC, new Java class, type in your new thing. So I'm going to do hello world, no spaces in there, enter. And so now notice it has public class, and this is where we're going to put our program, is in this public class. Yeah, enter, and then you type in the main method. Main method, like I said, this is the same for any program. There's very little ways that you can deviate this, but you do public static void main, capital string, and then these 2 brackets, args. So capitalization is important. It's got to be the same of these, got to be in this order. And this is what it looks like. Let's see. And then we'll do, let me actually zoom this in. So this will make it a little easier to see. And so now right below the main method line. And so notice that this is in the main method block, because notice that we open here and we close here. And you can, when you put the braces here, it's both of these are yellow, so it's signifying that it's this main method and it's inside the programming thing. Then we have system.out print ln, and then we just do hello world, 3 exclamation points. And then remember, so this is a line, so we need to punctuate it with a semicolon. And then when we run this triangle right here, we compile it, thinks about it for a second, and then look, it says hello world right there. Great, right? Now we can make it say hello world. This is the computer. See, we could change it to say whatever we want. Anyways, play around with it. Give it a try. See how it does for you. Really, the idea is like, I want to make sure we can get to the point where we can install these and get these to work. And you know it can work because if it's printing these things for you. Okay. Anyways, I think that's good for today. Hopefully you found this useful. If you need a link to, if you want to refresh yourself on the topics and stuff like that, there's a link to the last video at the end of this video. In all my videos, I have a link to the previous video. So if you need to refer back to it, it's there. Anyways, I think that's good for today. See y'all later. Bye. Hey everyone, hope you enjoyed that video. If you did, please press the like button below. It lets me know I'm doing something right. If you have any questions about any of the content, please send a message to both me and the rest of the teaching team in Canvas, and we will get back to you as soon as possible. Don't send it through normal email. You will not get as fast response. If you have any suggestions for how I can make these videos better, please leave in the comments below. Don't forget to roundhouse kick the subscribe button and ring the bell to get notified for the next video. Anyways, I think that's good for now. See y'all later. Bye.